Okay, we're going to go into Unit 7, Section 2 now and look at the problems that are in this section of the notes, mass to mass conversions. Okay, so I'm really just going to skip through and get to the examples because hopefully you've been in class and you've heard the lecture. And if not, I guess you can read through. But this is just a really simple example of a mass to mass conversion. And it's really just basically, with the whole law of conservation of mass. You have to have the same amount on the reactant side as you do on the product side. So if you have 15 grams of ammonia, and let me write on this so I can show you visually. Um, if you have 15 grams of ammonia, which is right here, and you had 5 grams of hydrogen, they want to know what the mass of nitrogen would have to. Like I said, this is a very overly simplified example, but if you have 15 grams on this side and there's 5 of this reactant and you only have 1 reactant left, you're going to have to put some number here that's going to add together to create 15. So you would have to have 10 grams of nitrogen, add those together, and hey, look what you get, 15 grams. So again, this is an overly simplified example of how the law of conservation of mass works. Okay. All right, so let's look at here the checks for understanding. Again, this is not stoichiometry, which is, the whole math based go through and figure out molar masses and all that. This is, again, an overly simplified example of what we're doing here, demonstrating the law of conservation of mass. Okay, so this is how many grams of product Z, we need to figure out how much is going to go here, will be formed if you had 12 grams of W with 10 grams of X. Okay, and they tell you also have 8 grams of Y. Well, what do these things add up to? They add up to 22 grams. And you have 8 grams here. So you got to figure out what would go with Z to create 22 grams on this side. Because again, remember, they have to balance. So if you just do the math in your head, hopefully you figured out you had to have 14 grams here, and 14 plus 8 gives you 22. So your answer is letter J. Again, very, very simple, but it's just a basic concept of the law of conservation of mass. Okay, on to the next. Back to our bread and cheese. Okay, so really with this example now, they're talking about where, they want to know how many pounds of cheese. And, if a pound has 16 slices, you had to figure out, it's just a conversion factor, which is what we're going to be doing. Stoichiometry is just one of those things. You got to find a way that works for you and take it step by step. Okay. You could possibly use this, and this is fine. This is just giving you like a flow chart of, if you're given one thing, the different steps you have to go through to get to the other. And I'm going to walk you through several of these in this section. So let's look at example 1. How many grams of oxygen? And maybe if I get right on the screen, that would be really cool. There we go. How many grams of oxygen are required? And there's my oxygen to completely burn off 65.4 grams of ethane. And this is ethane right here. All right, so you can see we're working with grams now and not moles. So it gets, you have to add that extra step in there. So let's take a look. We're going to need the ratios eventually, but I guess the first thing we need to do is we got to convert to moles. That, to try to get us there, and then we'll look at the ratios and convert back. But anyway, all right, so let's look at ethane, which is C2H6. What is the molar mass? All right, so we have, if you look on periodic table, carbon's atomic mass is 12 times 2, going to give you 24. Look on the periodic table for hydrogen. Its atomic mass is 1, but we have 6 of those. 6, so we have 30 grams per mole of C2H6. All right. So we have to convert what we have, and we know we have this many grams. So let's start with what's given. All right, and we got to convert that to moles. Well, 1 mole is equal to what? We just said 30 grams. All right, we'll put the grams down here so they will cancel out. If you plug this into your calculator, you should get 2.18 moles of C2H6. All right, so now we can compare our ratios, because look, we know that there are 7 moles of oxygen for every 2. So let's look at that. 2 moles of C2H6 to every 7 moles of oxygen. But what we got to figure out now is how many moles of oxygen we're going to have with just, it's a little more than 2.18 moles of C2H6. Okay, so now we set it up like we did before. All right, plug all that in a calculator. You get 2x is equal to, what is it, 15.26. 7 times 2.18 is 15.26. Now just solve for x. And you should get 7.63 moles of oxygen. So that looks about right, because look, before we had a 2 to 7 ratio. Now we're a little over 2 for the ethane, and we're a little over, 7 for the oxygen. So that looks right. That's our new mole ratio. All right, we got one more step to go. They want to know the number of grams of oxygen. Well, we know we have this many moles. Now we got to convert moles to grams. All right, I know I don't have much space. I tell you what I'm going to do. I'm going to get rid of this because that was pretty easy to figure your molar mass of ethane. So we don't need that anymore. All right, so, well, I guess we need to figure out the molar mass of our oxygen. Y'all can do that in your head, but let's write it out. Molar mass of O2. Look on the periodic table. Oxygen is 16. There's 2 of them. So that means there's 32 grams per mole for O2. All right, we're going to need that to convert. So we know this is how many moles we have. 7.63 moles O2. All right, and now we're trying to get to grams. Okay, so for every 1 mole of oxygen or O2, we know there are 32 grams. All right, so now we can kind of cancel out the moles because we don't want that. We want the grams. If you plug this into the calculator, 7.63 times 32, you should get 244. Oops, not a decimal. Come on, Miss Taylor. 244. 244. That's supposed to be a 2. 0.16 grams of oxygen. So there's your final answer. Again, lots of steps on that one. Okay, clearing this out. All right, there's your final answer. All right, let's move on to number 2. All right, so again, we know we have 65.4 grams, so that number hasn't changed. But now they're asking how much of the CO2 we're going to get. Okay, how much is that going to be produced? All right, well, we already know the moles of this because we figured it out in step 1. We said there was 2.18 moles of C2H6. All right, and what they're asking now is how many grams, but we still got to figure out the moles first, and then we can go back. So we don't know how many moles of CO2 we're going to get with 2.18 moles, because what we do know is that in the equation it shows you there's 2 C2H6s for every 4 CO2s. All right, so let's work that out. 2 over 4, and we have 2.18 is what we actually have, and they want you to figure out how much CO2. So that's 2x, and then we have 4 times the 2.18. That's going to give you 8 point, I'm trying to find where I wrote it, 8.72. Okay, solve for x. X is 4.36 moles of CO2. Now that looks right too, okay, because normally we have 4 for every 2, but remember we're slightly above the 2 mole, mark with the C2H6, so you should realize you're going to be slightly above the 4 for CO2. All right, and now we just got to convert to grams. So we got to convert 4.36 to grams because they want it in grams. So let me clear this screen. And we know we have 4.36 moles of CO2. All right, well, we got to figure out the molar mass of CO2. All right, carbon is 12, that's the atomic mass, and then we have 2 oxygens, so 16 times 2 is 32. Add those together, and you get 44 grams per mole for CO2. So 1 mole of CO2 is equal to 44 grams, okay? So cancel out your moles, because we don't need that, and really you're just putting the 4.36 times 44 into your calculator, and you should get 191.84 grams of CO2. That is the final answer for this problem. Okay, 191.84. All right, let's look at a couple checks for understandings. If 3.50 grams of hydrogen sulfide are used in the above reaction. Okay, so we are looking at, let me get my pen going again. So we're looking at this. What's the theoretical yield of water in grams? Okay, so basically, normally what we have, or at least with the way the equation reads, the ratio is 2 of these. And this one's pretty easy, for every 2 hydrogen, 2 waters. So if you have 3.50 grams of that, then we are going to be looking at, we got to figure out how many moles. Okay, and then once we figure the moles, we got to figure the mass. All right, so let's convert, we got to get the molar mass for this. So we have hydrogen, atomic mass is 1, there's 2 of them, that's 2, and then sulfur is 32 atomic mass. So 32 plus 2, so we know that this one is 34 grams per mole. And for water, its molar mass is, we have H, atomic mass is 1 times 2, so that's 2 grams for that. We have 1 water, that's 16. So 18 grams per mole for water. All right, so we're going to be using these. All right. So we know we have 3.5 grams. Actually, let me erase this. So let's convert our grams to moles. 3.5 grams of H2S. 1 mole is equal to, we just calculated it, 34 grams of H2S. We can cancel those out. And that is going to give us, if you plug that in a calculator, 0.103 moles of H2S is what we're working with. All right. Well, again, let's go back to this ratio. So whatever ratio you have of H2S, you have the same ratio for H2O when it comes to moles. So you know if you have 0.103 moles of HTS, you're also going to have 0.103 moles of water. That's why I said this one's a little easier, because now you know how many moles of water you have as well, because the ratio is basically 1 to 1. So moles. Okay, and we got to convert, we got to figure out the number of grams in the water we have. So this is where we are going to go for every 1 mole of H2O. We said we had 18 grams. Okay, and when you plug that into the calculator, you should get 1.85. Oh, wait a minute. No. Let's try that again. When you plug that into the calculator, you get I think I said it right. I didn't write it right. 1.85. I got 8. Is that right? Yeah, 854. You can round it or whatever. Anyway, your answer's right here. They rounded it to 1.85, so I guess we don't need that there. And this is grams of water. All right. All right, let's look at number 3. The number of grams of oxygen. So we're looking at oxygen required to complete the combustion of 4 grams of methane. So we're looking at oxygen and methane. All right, so this is a ratio of 1 to 2. All right, well, we know we have, what do they say, 4 grams of methane. So we got to figure out how many moles are in 4 grams. So I guess we got to do our molar masses. Let's do that. C has 12 grams, and there's 1 in there, but we have 4 hydrogens, so that's 4. So 12 plus 4, that's going to be 16 grams per mole for this. All right, and we know we have 4, so start with what you got. We have 4 grams of methane, and we know that 1 mole of methane is equal to 16 grams. Those will cancel. If you plug this into the calculator, you get 4 divided by 16. That's going to give you 0.25 moles. Okay, so that's how many moles are in 4 grams of methane. So now we got to figure out how many moles of oxygen is needed. All right, let's look at our ratios. We said we had a 1 to 2 ratio. So that's 1 over 2. And we know that we have only 0.25 right now of the methane. But we don't know what we're going to get or what we need with oxygen to react with just 0.25 moles of methane. All right, so just do your cross multiplying. 1 times x is x. 2 times 0.25. Y'all can do this in your head, but we're going to need a half a mole of oxygen in order for this to work. And now you just have to convert half a mole to grams. All right, so the molar mass of oxygen is, the atomic mass is 16. We have 2 of those, so it's 32 grams per mole. Okay, don't know why I put an E on the end of mass right here. I think I was going to write masses, but anyway. All right, so we know we have 0.5 moles of O2 and 1 mole of O2 is equal to 32 grams. All right, this one you should be able to do in your head. What's half of 32? 16 grams of oxygen. So that is our final answer. Finally, 16 grams of oxygen is needed for the complete combustion of 4 grams of methane. All right, gotta flip the page. All right, let's look at number 4. What mass of nitrogen is required to react with 16 grams of nitrogen? All right, we know we have 16 grams of I think I said nitrogen. Anyway, we have 16 grams of oxygen. So what mass of nitrogen is needed to react with 16 grams of oxygen? All right, let's look at our molar masses. I'm going to go ahead and do both of those up here right now. N2, if you look at nitrogen, it's 14. We have 2 of them, so that's 28 grams per mole. And then for O2, we just did that one. We'll do it again. 16, we have 2 of them, so that's 32 grams per mole. So there's our atomic mass, molar masses for those when we come back. All right, number 4, how many moles are in 16 grams? So let's figure out the number of moles in 16 grams of oxygen. I'm going to get rid of my picture too because it's taking up space. There we go. So 16 grams. We want to know how many moles we have. And how many did we say were in 1 mole of O2? We said there was 32 grams. Cancel that out. End up with 16 over 32. So you are going to end up with half a mole. Okay, so we have half a mole of oxygen in those 16 grams. Let's take a look at our ratios. All right, we're looking at nitrogen and we're looking at oxygen. Normally we have 2 of those to every 5 oxygens. They want to know the mass of nitrogen, so we don't know the number of moles that will react yet with, and we just said how many moles we had, 0.5. So set it up, 2 over 5, x over 0.5, 5x, like I said, just solve it, over 1, 5, 5. So your x is equal to, if you plug 1/5 into the calculator, that's 1 divided by 5, you end up with 0.2 moles of N2. All right, unfortunately, that's not good enough because they want mass. So we got to figure out the number of grams that are in 0.2 moles of N2. So we know we have 0.2 moles of N2. And 1 mole of N2 is equal to, what do we say? Go back up here to our molar masses. We said 28 grams. All right, plug this into the calculator. 0.2 times 28, you're going to end up with 5.6 grams of nitrogen. Okay, so that is your final answer, 5.6 grams of nitrogen. All right, and I'll clear this so we can work on the next one. All right, number 5. The reaction for the decomposition of ammonia can be written as shown. If a student starts with, all right, we're looking at how much ammonia he's starting with, how many grams of hydrogen gas will be produced. So now we're going to be comparing these two. All right, well, they told us that we had this many grams. Always start with what you're given. All right, we got to convert that to moles so we can do our little ratio. All right, so let's do our molar masses. Go ahead and do them both for NH3. So N is equal to 14. H is 1, but we have 3 of those. So we just add the 14 and the 3, and it's 17 grams per mole. Per mole, I guess I don't need to add. And then we'll go ahead and do our hydrogen as well. We already said hydrogen has got a mass of 1, but we have 2 of those. So that's going to be 2 grams per mole. Okay, so we'll come using these. We're going to use the ammonia one first. All right, so let's convert the 21.7 grams of NH3. We're going to convert that to moles. 1 mole of NH3, we said, was 17 grams. Cancel the grams out because we want moles. So when you plug this into the calculator, you should get 1.28 moles in H3, okay, that are found in those 21.7 grams. All right, now let's look at our ratios for NH3 compared to H2. All right, so if you look at our equation, there's 2 of those for every 3 hydrogens. But now that we know we only have 21.7 grams, and 21.7 grams is 1.28 moles, we want to know how much H2 we're going to get when we only have that many moles. All right, so let's look at these ratios. So it's a 2 to 3 ratio. And now we have 1.28 moles, and we're trying to figure out how many moles of hydrogen gas. 2x, and then 3 times 1.28 is going to give you 3.84. Solve for x, and you have 1. That's supposed to be a, back that up a little bit. X is equal to 1.92 moles of H2 gas. So that's how many moles you're going to get. But again, we're not done because they want to know the grams. So we know we have 1.92 moles of H2. And we got to convert it to grams. And how many grams are in 1 mole of H2? We figured it right here. 2 grams. Our moles cancel. And then we just take the 2 times the 1.92, and you end up with 3.84 grams of H2. So that is our final answer. And that is letter, close enough, letter H, 3.85. All right, I think that might be the last one for this section. Let's take a look. Yep, okay, so that's the last one. So again, guys, if you have questions, please email me or talk to me while we're in the Zoom. And you guys have a great day.